Hi everyone, thank you so much for joining us today for this speaker session. We have with us Bradley Kim. Bradley is a PhD student in electrical and computer engineering at Seoul National University under the supervision of Professor Young Chun. He completed his MS degree at KAIST where he was advised by Professor Jong Chul Ye. This year he is interning at NVIDIA Research working with Umar Iqbal, Xueting Li and Ye Yuan. Last year, he interned at Google Research with Alonso Martinez, Krishna Somandepalli, and Yu-Chuan Su. His research focuses on artificial intelligence, particularly in computer vision and its intersection with generative AI. Thank you so much, Bradley, for your time, and I'll pass it over to you.
Okay, thank you for the introduction. Yeah. Hi, I'm Gwanghyun Kim at SNU and author of BeyondScene, Higher Resolution, Human-Centric Scene Generation with Pretrained Diffusion. Thank you for the great opportunity to introduce our research at core here for AI. Okay, so here's my short biography. So as introduced, I'm now PhD student in Seoul National University, and also I'm now research scientist intern at NVIDIA Research, and also I was student researcher at Google Research last year, and yeah, I got several awards like the Google Conference Scholarship this year, yeah, and from Qualcomm Innovation Fellowship, yeah, and others. And my research focuses on AI, particularly in computer vision and its intersection with generative AI. So yeah, my work explores three key areas like multimodal generative AI, um, such as image, video, text, audio, yeah, kind of 3D geometry like that, motion, and also high-dimensional generative AI like image over 8K resolution or yeah, video 3D, 4D like that. And also I'm interested in human-centric generative AI, like human face, digital humans, and human-centric scenes. Yeah. Other than this, also I'm interested in distributed learning and weekly and self-supervised learning as well. So yeah, yeah, there were several works from me, like on image, like first one was Diffusion clip, which was accepted to CFIR um, um, 2022, and it was on image manipulation. So it was yeah, it was really great that kind of glide from OpenAI and Imagine from Google cited my work, and so my work was highlighted by yeah, many researchers. So yeah, I was happy to I was really proud of this work. And yeah, BeyondScene, which is the work that I'm going to present today, introduce today, which is about higher resolution human-centric scene generation with pre-trained diffusion model. So yeah, it is like it can generate kind of 8K by 8K super higher resolution images with details including kind of human-centric scene. Also, yeah, I have several works on 3D, which is Daily 3D and Polia 3D, which is diversely preserved domain notation using text image diffusion for 3D generative model. So this work is like, yeah, there are several kind of 3D generative model, and the first one was like EG3D, like yes, 3D GAN. So, but it was really tricky to collect the data set to train this kind of 3D generative model. So I proposed to fine-tune this kind of 3D generative model using diffusion models. So it was kind of daily 3D. And Podia 3D advances daily 3D to enable the domain adaptation of 3D generative model across large domain gap. So with the 3D generative model trained on human face, now we can generate kind of generative model 3D 3D contents like Earth or yeah other animals like elephants, Sonic, Neanderthal, or statue, Lego like that. Also, yeah, I have or yeah, this Dito Nerf is a work on 3D generative model from text, and it was yeah. Nowadays, yeah, there are so many great works on text to 3D generative model. So, but it was kind of um, pioneering work for the text to 3D generation, yeah, which utilize kind of inferring diffusion model to enhance kind of consistency for multi-view. Also, yeah, this work AVDIT and MONR, a versatile diffusion transformer with mixture of noise levels of for audio-visual generation, which is succeeded to release this year, which is which was the work at Google when I was a student researcher there. And yeah, it can generate diverse types of it can do diverse types of audio video tasks like audio to video generation and video to audio generation, and yeah, and audio video continuation. Then yeah, something like that. And nowadays I'm working on generative AI on dynamic 3D human at NVIDIA. And yeah, also yeah, I have several works on self-supervised learning and medical imaging like that. Yeah. So yeah, it's time to dive more into BeyondScene, which is which can generate exquisite human-centric higher resolution images with enhanced text correspondence and naturalness, and complex multiple humans and scene composition, and higher resolution and scalability. Recent text-to-image diffusion models have enabled to generate control of human scenes, such as like generating human images from this kind of post condition. So it was really great. However, scaling these to larger and more complex scenes with multiple humans remains a significant challenge. So these limitations stem from following causes like limited trained image size and limited text encoder tokens, and yeah, inherent limitation of T2I diffusion models. So like higher resolution images can involve a larger text, but current text image diffusion model can only incorporate kind of this limited number of tokens, and also um, some limitations of their model generate like this kind of very duplicated images with duplicated objects, and yeah. And there were several attempts to address training image size issues, such as kind of joint process and dilation-based methods. So representative works was joint diffusion from multi-diffusion. So this patch size is matched to the kind of training size of the diffusion model, text image diffusion models. So if we have kind of these image diffusion models, we firstly can predict the noise for each patches, and if there is a kind of overlapping region, we can average it. So by doing so, we can generate kind of this kind of simulated images. So yeah, this work was really nice for it, specifically for this kind of scenery images. However, this kind of works also not good for generate larger human-centric scenes. With like kind of unrealistic scenes such as human-defying gravity and physically distorted environments and duplicated objects like that. And also there is a kind of anatomical distortions generated scenes may show unrealistic human anatomy such as abnormal limbs or facial features. Also, it can include kind of limited text image correspondence. So as I said, like this kind of long sequences, long text can not be reflected to the images, generated images. So this is kind of challenges in current higher resolution image generation methods for large scene generation, large human scene generation. So to resolve this, we propose BeyondScene, a novel framework that overcomes these limitations, generating high resolution human-centric scenes with exceptional text-image correspondence, naturalness, and complex scene composition. Also, our BeyondScene can produce super high resolution image beyond 8K, surpasses kind of training resolution of SDXL by kind of 64 times. And these advancements have paved the kind of way for exciting new application in higher resolution human-centric scene creation. So our BeyondScene employs a statist and hierarchical approach, which looks similar to kind of classical multi-resolution manner, but it is closer to how artists establish a foundation before adding details. So it is consists of detail-based image generation part and instance-aware hierarchical enlargement. So let's take a look into detail-based image generation first. Firstly, individual given kind of pose and text input, individual instances are generated in the training resolution, for example, 1K by 1K using SDXL and using the post-guided T2I diffusion models. Next, generate instances are segmented, cropped, and resized into the desired size. And this allows for the kind of this detailed description beyond token limitations tailored to each individual. Next, a diffusion-based embedding method is employed to create instance-aware background that seamlessly integrates with the individual instances. To address potential inconsistencies in brightness and color tones across the instances, we also applied kind of tone normalization through constant kind of histogram equalization method. To enlarge this base image, we can use upsampling the image and perform joint diffusion process. However, this kind of knife stretch induces blurriness due to the model assigning sufficiently high likelihood to low quality outputs. Also, these strategies often encounters issues such as natural duplication of objects and human um, humans stemming from the uniform application of the same text prompt to our views without kind of post condition. So we applied we proposed instance-aware hierarchical enlargement, which is composed of high frequency injected for diffusion and adapt join process. Firstly, high frequencies injected for diffusion, which is enhances the enlarged output details while preserving contents. This technique injects the high-frequency details into the upsampling images based on Canny map, which improves image quality and reduces the flickering artifacts the borders. Specifically, we first upsample the low-resolution image and calculate Canny map. Gaussian blur is applied to the map and normalize it to get probability map. And random number is sampled from the uniform distribution at each pixel. So if the number is larger than the value of the probability map at each pixel, there is no change. On the other hand, if the number is smaller, the pixel value within a certain distance is replaced so that we could apply pixel perturbation adaptively to avoid flickering artifacts near borders. This is proceeded over our pixels. So this kind of this kind of change pixels can induce the high frequency injection on the images. Now, next we can perform the latent encoding and forward process. And to resolve duplication of objects and humans in the knife joint diffusion, we introduce adaptive conditioning and adaptive stride. For each view, we check which human instances are present, and if an instance is included, we add its pose and detailed description to the global prompt used for that view in the diffusion model. And this approach enable efficient and robust joint diffusion while maintaining control over crucial human characteristics like pose and appearance. And each view incorporates relevant text and pose information specific to the content using kind of adaptive pose conditioning and adaptive text conditioning. So yeah, so this kind of adaptive pose conditioning and text conditioning means that we condition kind of pose and text for each view, but in case of the knife joint diffusion, they utilize same text prompt and they didn't utilize kind of pose input for joint process. So now we can reserve kind of duplication of objects. And this kind of adaptive stride is utilized for enhance the efficiency of the generation during the generation process. So basically, we use larger stride on the background, and we use smaller step for the joint diffusion on the kind of human instances. So this means that for the human instances, we use more detailed joint diffusion, but for the background, which is less important than kind of human instances, we use larger step for the joint diffusion to enhance kind of efficiency. So this kind of joint diffusion process is repeated for our diffusion steps. So as represented in the results, our results show the less show a better results outperforms baselines, showing less duplicated subjects and also better uh, greater text image correspondence, and with this even this larger text, and also yeah, great anatomy and great kind of physics. Yeah. um, Conversely, kind of other methods generate images with artifacts. So yeah, this shows our superiority on kind of baselines. Yeah, these are other text inputs and yeah, the readers. Yeah, one thing to note is that yeah, our input is posed with this kind of text. So yeah, we compare our method with kind of ControlNet, which also utilize post and also T2I adapter as well, but they are not good for generating kind of larger human-centric scene, and kind of this kind of multi-diffusion scale crafter, which is the method for larger scene generation. They are not good for human-centric scene generation. Yeah. For the evaluation of kind of text image correspondence and global naturalness and human naturalness in quantitatively, um, we utilize global clip score and multimodal language, large language model, GPT-4 based metrics, which was proposed in other works, which is called Visor GPT like that. And one thing to note that is global clip score is not good for evaluating this larger scene, because clip it can only input, its input is limited into kind of 77 tokens, and also its image size is fixed to input image size is two kind of 200 by 200, so which is not good for evaluating larger scene, like super high resolution like that. So yeah, we utilize state-of-art multimodal language model, which input is image and longer text, and it, it is so we can ask some kind of questions related to text image correspondence, and this model can quantify the scores for related to this text image correspondence and naturalnesses. And in this evaluation, our model shows superior text image correspondence and naturalness compared to the baselines. And also we compare our method by the scene complexity. So our method exerts exerts very well, even in the kind of um, the larger number of humans, like from 5 to 8 humans, like this. Also, yeah, we um, proceeded kind of user study, and user our method outperforms others, preferred to other baselines, and this kind of multimodal language model scores closely aligned with human scores. And some people think um, kind of super resolution is similar to our hierarchical enlargement, but this kind of super resolution struggle to generate images that faithfully correspond to the text. So basically, it just kind of make the image from low resolution convert the low resolution image to high resolution image. So it didn't correct kind of the artifacts on those kind of faces. And these kind of artifacts are happen in case of very small cases, small part of the images. But our BeyondScene, our method, our enlargement enable to correct this kind of method across the stages. So yeah, even though the image from the base image was not that great, it can be corrected like this. So yeah, this is um, kind of big difference to the kind of super resolution method. And as I said, our method can incorporate kind of larger text prompt over 77 tokens. So for example, this kind of image are generated from this kind of longer tokens, and this image is generated from these tokens, this text prompt. And this image is also generated from this kind of larger or longer text prompt. Also, yeah, we conduct ablation studies to demonstrate effectiveness of high frequency injected for diffusion. So, so this high frequency was injected to like by kind of changing the location of pixels. So if we don't use kind of high frequency injected for diffusion, the result was like, yeah, very um, like kind of blurry images. But in case of our adaptive pixel perturbation, it shows kind of the more sharp and yeah greater images. But in case of pixel perturbation on both on four or locations in around borders as well. I mean, in this case, it generate kind of artifacts around the borders. Also, we conduct a very study for the adaptive conditioning, and without kind of adaptive conditioning and post conditioning and text conditioning, there are many duplicated objects, and also yeah. But in our case, our method with adaptive conditioning shows better text and image correspondence without kind of duplicated objects. Also, yeah, this is ablation study on adaptive stride. So stride 32, which is detailed, but it takes longer time to the generate kind of images. When you use kind of stride 64, it's faster, but the quality of the generated images was not that great. But if we use kind of adaptive stride, the um, like the human scene human instances are generated greatly, while preserving the moderate quality on the background. Yeah, so this is the yeah. Thank you for listening our presentation, and yeah, feel free to ask any questions. And yeah, thank you. Is there any comments or questions?
Thanks for the talk. I wanted to ask if have you done any uh, have you tried to extend this model to video as well, like 8K video generation?
Oh, so are you asking our applying our method to video diffusion model, right?
Yeah,
Oh, yeah, actually, yeah, our future work is, yeah, applying our model to, yeah, kind of video diffusion models. But yeah, currently, um, yeah, it is just working on, and it kind of video diffusion model, yeah, consumes more resources. So yeah, currently our laboratory has some issues on resources, so it is stopped. But yeah, we are going to, yeah, try that, yeah, as soon as possible. Yeah.
great. Also, I think it is very interesting because I tried one of the models that actually did super resolution. So it was a video
Mm-hmm.
super resolution model. And one of
Mm-hmm.
the problems in it was that there were some kinds of artifacts that were introduced
Mm-hmm.
on face, and it would give a feeling that this video is upsampled. So I think the quality of details in this is really interesting, that it does not feel
Mm-hmm.
like there is some supernatural super resolution applied. So I think that's really
Mm-hmm.
interesting.
Yeah, thank you for the comment. Still comments. Oh, yeah, thank you, Kartik.
If we don't have any question, we can conclude the session here.
Okay. Yeah, thank you for listening our research. Oh, Kartik.
Yeah, I have a simple question. It might be dumb, but I just wanted to ask. So the humans, the project is mainly concentrating on improving the resolution of mostly
Mm-hmm.
human-centric. But
Mm-hmm.
is it also improving the background quality in pixelated? Does it also does that?
Yeah, right. Yeah, actually, yeah, our method improves the kind of quality of the background as well. Yeah, um, but we wanted to emphasize more human instances, because yeah, previously it was really difficult to generate um, higher resolution images with human-centric scenes. So yeah, so we can utilize kind of post-guided diffusion for, yeah, this larger image generation, so we can achieve the background and human instance both. And yeah, actually, this kind of larger image generation, um, they are they because of kind of duplicated object artifacts, their background also quality was not that great. But our research um, um, reserved kind of artifacts, so background quality become also, yeah, greater than this kind of, yeah, works.
Interesting. Thank you for the information. Also, one more question is that what is this image size of your outputs?
Oh, so are you asking the kind of maximum size, right?
Yeah. Like how
Yeah,
much MB
yeah,
megabytes?
yeah.
It's
Actually, we our kind of maximum size was kind of 8K by 8K, so which is kind of, yeah, yeah. But it takes it took kind of 1 hour to generate this kind of resolution, and maybe
I see.
kind of, yeah, gigapixel images. We can, yeah, theoretically can we can generate kind of gigapixel images, but it took, yeah, really longer time. But recently, there are several great methods to reduce the time for joint diffusion by utilizing kind of kind of parallelizing the kind of diffusion paths. And also there are several methods to accelerate larger image generation. So we are also thinking of kind of accelerating our methods. Then maybe we can utilize, we can generate the higher resolution than kind of 8K. But kind of GPU resource in terms of memory, like it is same for all kind of size. So yeah, theoretically, if we have enough time, we can generate. Yeah.
Last question is that since we are also talking about the speed, the time it is taking to generate an image. So you just mentioned about the joint diffusion method, but what are your thoughts on the progressive diffusion distillation method?
Oh yeah. Actually, we didn't utilize kind of distillation method for this, but yeah, for example, yeah, we utilize SDXL, but SDXL turbo, which utilize some kinds of distillation method. So when we use that kind of method, maybe we can reduce our generation time kind of by portal like that. So maybe it is really good idea to utilize kind of distillation method and distillated diffusion. And I also found that there are several works using Mamba for diffusion, and which was good for generating images very quickly. And so maybe those kind of distillation method and accelerating diffusion model can also apply to our method to accelerate the generation process.
Nice, thank you so much. Yeah, I will go read about the Mamba. Thank you.
Thank you. Okay, so if there is no question, I will conclude the session. And thank you for listening. And feel free to ask any further question by email. Okay.
Good.
Bye.
Thank you. Thank you so much for your time. Take care.
Bye.
Bye.
Thank you.